Welcome to the latest episode of our podcast, where we dive deep into the fascinating world of technology and programming languages. Today, we're exploring a cool new tool that pushes the boundaries of regular expressions. So if you've ever wrestled with text patterns in coding and thought, there has to be a better way, this episode is for you. Let's kick things off. Have you ever thought that regular expressions are a bit, unnatural for text editing? I know I have. Regular expressions are great for searching patterns, but they can feel clunky when it comes to transforming text. Today, we're discussing something that's a game changer: transductive regular expressions, or as I like to call it, trre. So what exactly is trre? Imagine you're trying to replace cat with dog in a string. Instead of worrying about ambiguous syntax and complicated processor logic, trre allows you to use a simple notation. Picture this. You use c0stya in a command line, and voila, you get dog. Isn't that neat? But wait, there's more. The beauty of trre doesn't stop at simple replacements. It can also delete characters. For instance, if you have XOR and want to remove the X, you can simply run a command that translates X to an empty string. It's like magic. Now let's get a bit more complex. Ever heard of the Caesar cipher? This is where things get really exciting. With trre, you can implement a Caesar cipher to encode and decode strings. So if I tell you Caesar cipher translates to DBF, TBS, DJQFs, it's like unlocking a secret code right there. But let's talk about some unique features. Trre can generate multiple outputs for a single input. Instead of just getting one response, imagine getting all possible combinations from a binary sequence of 3 digits. You run the command and boom, 000, 001, 011, 100, 101, 110, 111. It's like opening a treasure chest of possibilities. Speaking of features, let's touch on the technical side a bit. Under the hood, trre uses a special structure known as a finite state transducer, FST. It's like the cousin of the traditional finite state automaton, but designed to handle input-output pairs rather than just plain strings. This transition allows trre to define a binary relationship between two languages, and it's what makes it powerful. Now, I can hear some of you thinking, what about performance? Great question. The non-deterministic version of trre may lag behind in speed compared to tools like sed for simpler tasks, but it shines brightly when the complexity ramps up. For certain intricate operations, the deterministic version of trre can actually outperform sed, showing off its agility. As we wrap this up, let's reflect on what makes trre so compelling. It simplifies complex transformations, opens up new ways to work with text, and allows for both creative expression and efficiency. It's still in prototype phase, so if you're tempted to use it in production, I would advise holding off, at least until it's fully fleshed out. Before we say goodbye, I'd like to leave you with a thought. Can you think of scenarios in your coding life where trre might save you time or make your work easier? If you can, we'd love to hear your stories. Thanks for tuning in today and exploring the world of transductive regular expressions with us. If you enjoyed this episode, share it with friends, and don't forget to join us next time as we uncover more tech wonders. Until then, happy coding.